So, differentiation is one of the most beautiful parts of mathematics, and it came to being when scientists were discussing on the definition of a straight line. Straight line. So, suppose we have a given point, then we can say that um, there can be many lines which can be drawn from that point. So we can see yeah, there are infinite number of lines which can be drawn when we have only one point. But suppose we have 2 points, then there can only be one point. So when we have 2 points, only one line can be drawn. And if we take the axes, the um, y-axis and the x-axis, then we get suppose we get a line like this, and we have the two coordinates. Say we have these two, this one is x1 comma y1, and this one is x2 comma y2. Then a slope, also known as the gradient, is equal to y2 minus y1 by x2 minus x1. So we know that this triangle represents delta. So a slope is delta y by delta x for a straight line. Suppose we are considering a curve. Suppose we are considering a curve like this. Then if we consider the points, in this point the gradient will be this. Suppose we are considering this point and this point. Now if we consider this point and this point, sorry, and this point, and later on we will consider this point and this point. So let's name them point A, B, C and D. So for point A and B we know the slope. Now let us take A and C. This is the slope for A and C. And if we take AD, then this is the slope. So if we draw them, I will just draw the AC slope in a neater way, which will be like this, something like this. So we can see that the slope as we go towards D is getting farther away. So we can say that if we come closer from D all the way till A, then the slope of, suppose we have a point X, and this point X is going towards A, then the slope XA becomes not becomes of slope of XA comes nearer to AB as we move from X, as we move from D to A, right? So we can see in that diagram, when we move from D to A, the slope will become similar to AB. So in that way we can say that dy dx is the slope of a curve, and we can see that the slope of a curve, as we saw in this graph, the slope of a curve will change, right? So it will be variable depending on the value of x. So we can say dy dx depends on x. So we can solve one. Suppose we have y equals 3x square minus 5x plus 1. So here the slope dy dx will be equal to 6x minus 5. Now this leads us to another question, that suppose we have a curve like this. In this curve we can see that this point and this point, they are the minimum points, or they are also referred to as the minima. They are the local minima because maybe in the whole curve we have another minima. If the curve continues, suppose here, and it becomes something like this, then the lowest value would be the absolute minima. Similarly, this thing, the peak, is known as the local maxima. So in this region, in the local neighborhood of this point, the slope is decreasing in both the sides. Similarly, for this point, in both the sides, the slope is increasing. Now we go on to how can we find whether the point is a maxima or a minima. For this we use something known as the second derivative test. So what the second derivative test is, we find the derivative dy dx of the derivative. So dy dx. So for example, in this case we found dy dx is this, and then we will have to find the derivative of 6x minus 5. So that is represented by, if we multiply these two, we get d square y, we get d2y. So we have two d's, dd, dy, d2y, and dx square, because we have 2 dx into dx square. So for the example we took in the beginning, y is 3x square minus 5x plus 1. dy dx gives us 6x minus 5, and d2y by dx2 gives us 6. Now from this value which we get, we do not always get a constant. Sometimes we get d2y by dx2 as a variable term which has x, but here we have a constant term. But even if we get a constant or a variable term, how can we find out whether the graph is increasing or decreasing? So for that, when d2y by dx2 is greater than 0, so it is a positive value, then the derivative is, then the curve is minimum at that point. And if we get d2y by dx2 as negative, then we get a maximum point. So let us do an example so that this becomes more clear to us. So we have y is equal to 2x cube minus 9x square plus 12x minus 5. So here dy dx is equal to 6x square minus 18x plus 12. And here we can find the turning points from this, and we can do so by factorizing it. So it will be 6x square minus 12x minus 6x plus 12, which is 6x, x minus 2 minus 6x minus 2, which is 6x minus 6x minus 2. So we know that for turning points slope is 0 or dy dx is 0. And if you do not know how this comes, then it comes as, suppose we have a curve here and this point is the turning point. So if we draw a straight line at this point, the x value will be different, y value will be same. So say we have y1 x1y and here we have x2y. So the slope is y2 minus y1, so both are same, by x2 minus x1. So this gives us a 0. So 0 by anything will give us a 0. So from this we can say that for turning points we get a slope which has a value of 0. So from this we can say that 6x minus 6 into x minus 2 is 0, or x equals 1 or x equals 2. Now we find the second derivative. d2y by dx2 will be the d dx of, we had got 6x square minus 18x plus 12 plus 12x minus 18. So when x is equal to 1, we are considering x is equal to 1 out of this case, and then first, and then secondly we will take x to be 2. So when x is 1, d2y by dx2 will be equal to 12 minus 18, which is minus 6. Minus 6 is a negative value which is less than 0, so we can say that this is a maximum point. Now let us consider the second one, which is when x is equal to 2, then d2y by dx2 is equal to 12 into 2 minus 18, which gives us a positive value, which is 24 minus 18, which is 6. So this is a minimum point. So we know that the graph is a cubic graph and the graph will have a maximum at x equals to 1, and the maximum value of y will be equal to 2 into 1 cube minus 9 into 1 square plus 12 into 1 minus 5, which gives us 2 minus 9 plus 12 minus 5, which gives us 14 minus 14, which is 0. So the maximum value is 0. I hope you have understood the meaning of second derivative test to find turning points, and that's all for today.